The nighttime sky, glittering with stars of various brightness and colors, form pictures that capture the imagination. Astronomers have long wondered why the stars are so diverse, since they are born out of the same material that lies between the stars, vast clouds of hydrogen and dust. Gleaming brightly in the winter sky is the constellation Orion, the Hunter. Located only 1,500 light-years away in Orion's sword below the belt is the Orion Nebula. This immense gas cloud and intricate filaments formed by the interstellar medium is the brightest, youngest star-forming region close to Earth. This target was so appealing to astronomers that they used all of the instruments on the Hubble Space Telescope to take snapshots of the nebula. The parallel images of the Advanced Camera for Surveys, Wide Field Planetary Camera 2, and NICMUS provide a detailed mosaic to study the star formation history of the Orion Nebula.
We see the entire history of star formation printed into the feature of the nebula. We see arcs, rings, blobs, pillars, and each one tells us something about the encounter of different winds, about the ejection of material from stars in different evolutionary ages.
The four brilliant stars at the Orion Nebula's center are called the trapezium. When the gas in Orion's interstellar cloud collapsed under its weight, oatmeal clumps of hydrogen and dust were formed. The density and pressure within the center clumps caused a nuclear fusion and bore a trapezium star. An intense illumination ignited, releasing energy and stellar winds. This energy pushed open the interstellar cloud and formed a bowl-like cavity. When winds collide with other material radiating from the cloud, a bow shock is formed. The nebula's right side forms a rippling, curled edge from the impact of shocks on the dust and gas. The outflow from smaller stars near the rippled edge cut through the stationary gas and formed beautiful, elongated jets. A thin veil of dust and gas overlaps the shallow bowl shape. Hubble's resolution reveals thousands of stars surrounding the highly illuminated area of the four trapezium stars. For the first time, an entire star formation history is presented to us in a rich treasury.
In the case of the Orion Nebula, really the background is what kills ground-based observation. You need superb resolution to keep your stars like little tiny dots. If they are rings, disks, larger and larger depending on the atmosphere, on the blurring, then the background that you get is also so high that you lose sensitivity. I know that we got from Hubble basically 100 times fainter sources that were previously observed at this wavelength from the ground. So it's a big step. It's 5, 6 magnitudes is a big change, and actually opens new science. We see new, for the first time, brown dwarfs in the visible that were impossible to see from the ground typically.
Laid out on a plate for astronomers to catalog are over 3,000 stars of various ages, sizes, masses, and types. Red stars, blue stars, arcs, jets, protoplanetary disks, binaries, and now brown dwarfs. Seeing these fainter objects with the Hubble's Advanced Camera for Surveys, astronomers are able to study clearly disks and brown dwarfs. Brown dwarfs are so-called failed stars, objects that are too small to be ordinary stars because they cannot sustain nuclear fusion in their cores to glow. One of the most interesting findings is brown dwarf binaries, where two brown dwarfs orbit each other. This study will help solve the link between star and planet formation. Hubble revealed with its resolution in the visible light a rich tapestry of faint objects in the star factory of Orion's nebula. Hidden from view under the dense veil of dust and gas are the images of early star birth. To see stars as they first illuminated the universe, a telescope is needed with Hubble's resolution and the capability of detecting infrared light to pierce the dense veil. NASA is developing a telescope that will be able to fill these requirements, called the James Webb Space Telescope, or JWST. Astronomers worldwide anxiously await JWST to peer into the stellar nursery and see the first light of a star's birth.